Leveling is a technique used in engineering survey to determine the elevation difference between two distant locations. In engineering survey, elevation is defined as the vertical distance above or below a datum. For this lab, there are two objectives, which is to determine the height of specified places in relation to a datum, and second is to provide the data for road cross-section or volume of the earthworks.
Assalamualaikum and hi, I am Nurul Nabila binti Zul. My matrix number is AF200076. Apparatus and materials. There are 6 apparatus and materials that have been used in leveling transfer level fieldwork. The first one is automatic level, second is tripod, third is staff bubble, staff plate, and meter tape.
For methodology, first we need to do the field procedure. First, we need to do the observation procedure, which is first we need to consider the series of level loop data illustrated in figure 3.3. Second, we need to start at BMA. So the first measurement from setup 1 is a backside to BMA, and the first reading is the foresight to CP1, known as chain point. Third, we need to do the leveling stuff, then remains at CP1 while the instrument moves to setup 2. Take backside reading to CP1 and foresight reading to CP2 and so on. Fourth, eventually at setup 4, a backside reading is made to CP3 and foresight reading to BMA. Lastly, the traverse is then closed. This allows a check on the levels since the sum of all the changes in level should be 0. Second, we need to do the booking procedure. For booking procedure, we use the rise and fall methods. The terms that are commonly used in the rise and fall methods are BS equal to backside, FS is equal to foresight, IS is intermediate side, and RL is reduced level. Third, we need to do the reduction, which is calculation procedure. First, we need to check our survey accuracy and should be within tolerance given below or suitable for our project. This check should be applied before leave the job. Second, the following check the arithmetic of our level reductions and must be exact. Total backside minus total foresight equals to total rise minus total fall. Second, total backside minus total foresight equals to reduced level last PM minus reduced level start PM. Third, the mist closure should be plus minus 20 square root K mm, where K is the length of the traverse in kilometer. Lastly, for example, mist closure is and the length of the loop is 0.7 km. Hence, the mist closure limit is equal to 17 mm. Therefore, the mist closure of is too big, means that the leveling work is not accepted. For our result in this leveling, which is the transfer level, first we get the page check is 0.002 meter. Second, the end closure by using the formula reduce level bottom minus PM1 is 0.002 meter. Third, the allowable closure, which is plus minus 20 square root distance, we get 10 mm, and the adjustment by using 0.002 over 6, we get 0.0003 meter. For the data analysis, from the result above, the page check, which is 0.002 meter, the enclosure is 0.002 meter too, and the allowable closure is 0.010 meter. From the observation, the adjustment is calculated, which is 0.0003 meter. For the discussion, after completing the leveling project, there were a few errors happen. One of the inaccuracies occurred when the staff was not held vertically and the erroneous reading was obtained. This have an influence on the overall leveling calculation. Besides that, because of the traffic in that location, the staff are constantly moving from their original location, and it may cause the staff were not adequately extended or locked. Moreover, the chaotic refraction of light is caused by ground heating. The ray of light bends downwards in the form of a curve with its concavity towards the Earth's surface, which reduces the precision of the staff readings. Apart from that, the bubble was not in the center at the time of the reading. This might be happening due to carelessness when handling the instrument. Before calculating the closure, we must first check the page, compute and see if total backside minus total foreside equal to total rise minus total fall equals to reduced level bottom minus reduced level top. Then, if the page check is balanced, we can compute the closure. On this term, the end closure is smaller than the permissible closure. The closure is accepted and the adjustment can be calculated.
In conclusion, we had a great experience in hands-on during our fieldwork in leveling experiment. We can able to measure the vertical distance through the usage of leveling equipment during this leveling fieldwork. In this practical, we were able to complete all of the requirements and standards, such as reading the staff from the instrument position. Throughout the leveling observation practice, we read backside, intermediate side, and foreside. The leveling was performed from a known benchmark to an unknown TBM and then revert to the known BM. Then we calculate the transfer level from BM to TBM and then compute the level back to BM to ensure that our data is valid. By the end of the practical, we have met the objective in this practical, which are transfer of reduced level from BM to TBM and calculation of reduced level. All the readings data were hooked by the rise and fall method. Arithmetic check was applied in leveling method for verify the accuracy of calculations.